You are watching a tutorial on calculating bearings. Before focusing on bearings, we need to address direction. We are aware that when we refer to direction, we use 4 points: north, east, south, and west. We refer to these 4 points as cardinal points. It is important to remember the order of direction around a compass in order to correctly calculate bearings. Northeast, southeast, southwest, and northwest are points that provide more accuracy when referring to direction. To be even more accurate when referring to direction, we could use a 16-point compass. However, an issue arises when you want to identify the direction of a point precisely. Take your attention to the red arrow. It falls between northeast and east-northeast on the 16-point compass. Using the cardinal points to identify the direction would be quite confusing. This is when a geographer would use bearings. So what is a bearing? In geography, a bearing is an angle that is measured in a clockwise direction. When calculating a bearing, you must use the cardinal points. A bearing is always represented in degrees. Bearings are measured in a clockwise direction, with north corresponding to 0 degrees, east 90 degrees, south 180 degrees, and west 270 degrees. A full rotation back to north represents 360 degrees. So why do geographers use bearings? Geographers use bearings to give an accurate indication of the direction of one point from another. Let's have a look at an example calculating bearings from one point to another. In this example, we have 2 points, a blue point and a green point. The question at the top of the screen states, calculate the bearing of the blue point from the green point. This means you start at the green point. I will now outline each step taken to calculate a bearing. Step 1. Using a ruler, draw a straight line in a northerly direction away from the green point. This line represents north and 0 degrees. Step 2. Draw a straight line using a ruler from the green point to the blue point. Step 3. To work out what angle you need to calculate, draw a line starting from north until you hit the line joining the green and blue point. This is represented by a purple line on your screen. To calculate a bearing, you will need to use a protractor. Lastly, step 4. Align 0 degrees on your protractor with north. Calculate the bearing by using your protractor. The bearing in this example is approximately 47 degrees. In this example, I will be calculating the bearing of point E from point D on a topographic map. Firstly, using a ruler, draw a line towards north at point D. Then, draw a line from point D to point E, again using a ruler for accuracy. The angle or bearing which needs to be calculated is represented by the green line on your screen. Align 0 degrees on the protractor with north and calculate the bearing. It is clear that the bearing passes 180 degrees at south in this example. To continue to calculate the bearing from point D to point E, we need to align 0 degrees on the protractor with south and calculate the bearing stopping at the yellow line. It is clear in this example that the bearing is approximately 114 degrees from south. To calculate the bearing of point E from point D, we simply add 180 degrees and 114 degrees. Therefore, the bearing of point E from point D is 294 degrees. Lastly, I will address similarities and differences between bearings in mathematics and geography. Bearings are also known as true bearings in mathematics. A similarity between bearings in maths and geography is that the method remains the same. However, a difference is that bearings is represented differently in maths compared with geography. Let's go back to this example. The method taken to calculate the bearing in maths is the same as the method in geography. However, in maths, the bearing is represented in 3 figures. In this example, the bearing calculated in geography is represented in 2 figures following with the symbol for degrees, as seen in blue on your screen. In mathematics, the bearing is represented as 047 degrees, capital T for true. The angle is less than 100 degrees, therefore a 0 is placed before 47 degrees and a capital T is placed at the end to represent true. This concludes the tutorial on calculating bearings in geography.